All right, everyone, for our last session. Somehow people want containers. They are very excited about containers. They're excited about containers on different operating systems, all of whom do things very, very differently, but they often do it on ZFS. So over in FreeBSD land, UnionFS has famously been a wee bit explosive, and I believe Olivier is lined up to repair some of that. And so we'll first get a report from him on what he's planning to do, but I know that in the sea of things like whiteout support and layering and all that, Alan, it sounds like you once had a prototype that Rob later took a look at, and maybe there are other efforts that we're not even aware of. So let's kick it off, Olivier, with a description of what you're lined up to improve.
Sure. Okay, so the goal for this project for me is to be able to have a really stable and efficient UnionFS in FreeBSD. Unfortunately, I think the current implementation, the last incarnation dates back from 2006, 2007. It had lots of stability problems. But also design ones, unfortunately. I'm not really sure. Actually, UnionFS was pioneered in FreeBSD at the beginning of the 90s. I think that shortly after that, because of SMP and other multi-core developments, probably the VFS interfaces of the day were changed a lot. So I'm not completely sure, but I can say that probably it has been 20 years or more that it's not really usable in production as it is. I mean, you can use it for actually for several kind of simple scenarios, and it would work. But if you want something really production grade, I think, yeah, it was for a long time. We even had in the manual page some notes saying, okay, don't use it in production. And basically, the aim of the project is to fix that. And there are lots of things to do for that. There are the problem with the VFS and how it works in FreeBSD, and because actually UnionFS exercises a lot of these interfaces and in kind of weird ways compared to traditional file systems. So you have to be an expert of the VFS layer to actually be able to implement UnionFS. And you have to be such an expert for a period of time which is quite long. So it's difficult to have this expertise or knowledge or the people working on that. That's why the foundation wanted to fund something for this topic. Actually, I spent maybe almost 2 months full-time at the beginning of 2023, working on the full plan, that is to say, trying to see what are the current weaknesses in the implementation, where would we like to go, in which direction, which prior art is existing, for example, in Linux, because in Linux we have had several implementations of the same concept, different incarnations, such as one that was called UnionFS as well. But we have AUFS, OverlyFS now, which is the official solution. At some point, people in Linux were discussing about doing most part or maybe most of the functionality of UnionFS directly in the VFS layer, which I think was kind of ill-advised as the other events showed, and actually the actual choice of OverlyFS to be integrated into the kernel. So there is a first layer of things to change, which are basically in UnionFS, you have to respect a lot of invariants of the VFS in FreeBSD. So I would say it's the low-level part, but it's very important because obviously without that, you're not able to have stability or even production-grade system. But there is another layer on top of that, which is more high-level, and which is about okay, what should a union system do, actually? What do we expect from it? And what should it do exactly in a more higher level sense? And I think that there were no clear directions about that in the previous years in FreeBSD. So that's why I spent 2 months trying to have a big plan about what we should implement and how it should work. And it should be really clear and simple to user, at least as much as possible. Quite simple and quite intuitive to users. So basically, it's a complex topic, but if I had to summarize it in one sentence, I would say that UnionFS, when using UnionFS on some file system, basically we are trying to provide you with your own copy of the whole directory hierarchy, so that you can do whatever you want on it, and without actually modifying the original version of that hierarchy. Basically, that's that. You have to see it, for example, exactly as if you had done a full tree copy of the existing files, and then you modify them as you want without disturbing the original files. But actually, the point of UnionFS is doing that without a full real copy that would take space and sometimes a lot of time to do. We are just working instead with kind of delta approach, and at the file level granularity, which is really an important point to understand. At least in all the systems so far, we are only working on file granularity. It's not really, in general, it's not really a problem to have more fine-grained systems. They can be built on top of that, but at least from the point of view of the users, it's at the file granularity. So after having done this study part of 2 months, then I have worked on several other topics which are completely foreign to UnionFS. I hope to be able to really start executing the plan, because I have I made a plan that is supposed to last for 1 year and 2 months approximately, divided in 3 big parts. And the first part is really to have something working, and then the 2 other parts are more refinements, I would say, to stay simple. And I would like to start working on that normally at the end of this year. In the meantime, I've been working with some guy who has made some evolutions to UnionFS and tried to fix all the stability bugs, who is Jason Harmoning. He has worked for 3-4 years in his spare time trying to fix stuff. He had a bunch of field modifications that went in that I reviewed in the past 3-4 months. I think that this period now seems to have ended, so I should be able to take over at the end of the year once the current tasks I'm working on have been finished. And the goal really for me would be to have at least a working implementation usable in production, maybe not with all the bells and whistles, for FreeBSD 15. Which is due at the end of 2025. So here is in the great outlines of the plan. So maybe I don't know if you have some questions or even ideas. I'm quite interested actually in the scenarios you would have for using UnionFS. Obviously, I have a lot of them in mind, but sometimes we can have surprises or new ideas floating around. So. And in any case, I'm very open to being in contact with people that envision using it in production and for which purposes exactly. So
Any questions for Olivier? Garrett.
So this may be simply a matter of my unfamiliarity with the application, but why do you want to do this instead of just ZFS clone?
There are different reasons for that. I would say the first one is that with some UnionFS layer at the operating system level or in DFS, that means that basically it's kind of agnostic to the file system. So you could use it, for example, for UFS, which is the other main FreeBSD file system. Although obviously ZFS is taking more and more space here. Another reason would be that when you clone file systems in ZFS, at least up to this day, you are actually freezing the blocks of the file system or snapshots you're basing your clone on. So that means that once you've applied all the modifications, it's kind of one-way trip. You cannot really change, for example, the base where you applied your modifications. So I mean, maybe it's not that clear, so I'm going to reformulate. That means that if you have several layers, you have an original hierarchy of files, and so you would like to build some modifications on them, but at the same time, you would like, at some point, to evolve the base. This is a scenario that you would encounter, for example, when using jails on FreeBSD, or and managing them so that you have one layer which is the full system, full base system installed, and then you have several other layers which are separate based on that for your different containers, and you have different packages installed on all of them, etc. And the trick is that if you want to, for example, to upgrade your base, you want to upgrade your containers. One of the reasons, one of the possibilities, although I completely agree that it's not completely trivial, would be to instead of just updating all your containers one by one, you would update the base once and for all, and then you update only the configuration files if need be in your different containers, which are application containers. This is not something, at least in my understanding, that is currently possible with ZFS, but maybe there are plans to do that. I'm not sure.
It sounds like Jan has a question.
So I have a use case for this, so let me turn on my video. So my use case is similar, especially a more specific version of what Olivier sketched out, and that is I have a FreeBSD based system, let's say 14.2. Then there's a patch for that. I want to have a patched snapshot of 14.2 P1, P2, and so on. And this is my full basis. I want to store that once because copying 4 gigs of data around for every jail instantiation is a bit slow. And if you have a lot of jails, it takes up a lot of wasted space, especially space in the file system cache, because ZFS, if you do a send receive, will not know that these blocks are identical unless you use block cloning. So that you have multiple copies of libc and whatever in your ZFS arc, wasting main memory. At that point, it really becomes annoying. So you can work around with if the VFS knows that this is in reality the same file. It will just cache it once. So the other thing is the operational concerns about how you want to manage your jails. If you want to do something similar to the OCI image specification, where you start out with a workflow which is more built around tarballs than file system mount points, and map that onto your ZFS pool, you can't use clones because clones cannot be rebased. So any modification you do to a clone is locked into the clone unless you write something similar to ZFS diff to find all the modifications and kind of in user space copy them over into a new clone. They are locked there for good. And that's a lot of data movement you have to do. So it does not scale. Because you have to enumerate over all the files and then, or all the changes and then copy them over. Instead with the UnionFS, the hope, I would say, is that you can keep your overlay and the underlay can be changed by just unmounting and mounting the new patch level as your underlay, let's say via nullFS or by cloning it. And then you mount your existing jail with all its changes on top of that for a security update. That would, in my opinion, be very reasonable because you don't expect the security update to change the rc.conf or something. And you could have some process in place to make sure that there is no file in the overlay that exists in the underlay or something of the base system. And the other thing is that it lets you just mess around and basically get all the advantage of fin provisioning without the pains of separating things out into multiple data sets. Because I've spent a lot of time and effort figuring out ways to break up the parent-child relationship you normally have between your different types or kinds of use cases you have for ZFS file systems in a jail use case. Because there's this is basically an immutable image. It should be read-only. I only need to make it writable so that I can create mount point directories. Let's say you don't have user local in your pure FreeBSD base and you need it, or something under VARDB has to be created as an empty directory. And that's all the modifications. And you can programmatically recreate them so that while it is as part of your creation workflow for a few fractions of a second, a writable file system, it's effectively stateless, and you can recreate all the modifications by just starting the jail again with a fancy prepare hook. But the problem is that now you want to create something like VARDB Postgres or something, and it is a child of your clone. Untangling that parent-child relationship is fragile and annoying to script, and you only get to try it once, because once your automation has shredded someone else's production data, they're never going to trust you again. So instead, what you can do is you can, in ZFS already, basically have two levels of indirection with unmountable data sets, so that now your persistent data is not under my pool name / jails, name of the jail, and then VARDB or something, or / home something. Instead, it is now under two levels of indirection, one for the type, like persistent data, base system, packages, temporary data, which you roll back on every start, and then another one which is also unmountable, named after the jail name, with the mount point property set to /jails or whatever is the root directory of all your jails. And then you can have under that the normal data sets, and they are now inheriting the right mount points because you have two levels of indirection here, so that you don't end up with a mount point property in every top level jail data set. And it works out nicely, but it's a bit annoying to configure like that. And now you have untangled that parent-child relationship in a more distant relationship between them. And you can still run ZFS list sorted by mount point and pipe it into ZFS mount during your ZFS prepare hook. So that but all of this is unique to the way you set it up. There is no standard, and it's not interoperable with things like the OCI image specification and the way they are doing this overlay stacking, where you basically the semantics is do what GNU does, untar this archive, and then apply the whiteout files. And you just do that for every layer. the nicest thing about doing it the complicated ZFS way I just described is that you don't have to, at the lower level change, recreate the unaffected upper levels again. So if your FreeBSD base image has a security update, you don't have to recreate all the packages and so on. But with the UnionFS, you could also get that and remain compatible with the archive formats that have been established, at least on Linux, but not on FreeBSD because FreeBSD lacks any standardization around how to exchange jails. And yeah, UnionFS would be the luxury way to do it at runtime instead of having to template that or automate that out and instantiate it. It's like the difference between a view and a materialized view. So you don't have to materialize it because you can do it at runtime with low enough overhead in UnionFS. You get the best of both worlds.
Does that answer your
So
question?
you get the lower operational complexity and you get good performance.
So maybe, yeah, Michael, if I can say some words more.
Yes, please. I was about to inquire.
Just on what John said, or part of it at least. In the first step, I would like to get done at least for FreeBSD 15. Maybe there will not be all these refinements, but my final goal with UnionFS is actually to allow modifications of the layer concurrently with the modifications done through the Union view. It's kind of ambitious, but I think it has some practical advantages, which are beyond just updating the base. You could do that almost in live in some cases. I think it's best for a system to be quite well, at least as much as possible, to be quite well defined in behavior. For example, in OpenZFS on Linux, they explicitly say that there is no guarantee at all if you are modifying the backing layers at the same time as the Union view. They're just guaranteed that there are no deadlocks and no crashes, but you can convene that these are not quite strong guarantees actually, because you don't really know what will be the results of file system operations done on the view while you're updating the backing layers, for example, for hot upgrades or other scenarios like that. So really my aim, I know it's kind of ambitious, so we'll see how this turns out, but I would really like to go to a point where it's kind of very well defined what happens when you try to modify the underlying layers. So I just saw the question by Jan. No, actually, yeah, the function, the way I'm envisioning things for UnionFS is that we'll have, to simplify things, I'm only considering 2 layers. Actually, we can have more layers than that for mathematical reasons. That is to say, with the two-layer union operator, which is associative, actually you can build a union layer with how many layers you want. So it's not really a problem, except in some corner cases, but I'm not going to talk about them now. And basically you have 2 layers, and the upper layer is the writable one, and the lower one is read only, usually. In most scenarios, it's like that, and that's really, I'm going to concentrate on that functionality for UnionFS in FreeBSD, at least at the beginning. And one of the benefits of using UnionFS, so I just evoked now first my plan to try to be able to support all concurrent modifications to the upper layer, which is writable, but to the lower layer as well, which is read only from the point of view of UnionFS, but which is not really read only in the system, not necessarily, and usually we don't really want that. So I would like, there is this part, and another big benefit of UnionFS, actually, as you said, is that, and to build up on that, in UnionFS, the upper layer is a kind of, you can see it as a kind of patch or a kind of diff that you apply to the lower layer. So actually, the difference is really visible if you just look at the backing upper layer. Basically, it's the diff. I mean, it's a little bit more complex for files that have been deleted, which have to be materialized like with whiteout or opaque directories. But apart from the specific UnionFS metadata, it's basically a diff. And the advantage of working with a diff is that you can try to apply it to different bases. So that's true. That's I think an important point for scenarios that would require or at least be easier with that kind of functionality.
Any questions? If not, I'd like to segue into Rob's research on what ZFS could do better to perhaps do a tiny bit of heavy lifting that might bring some of these benefits to multiple OSs rather than, okay, here we are fixing it in FreeBSD and each OS has its subtleties and differences. And take it away, Rob. You are muted, but we'd love to. Oh, we have a question in chat or otherwise. On YouTube, there's a question. Microphone number 1, Patrick.
Jan was asking here, will the diff be by name or by inode?
Did you hear the question, Olivier?
Yes. No, in fact, the diff actually is by name, because that's how we actually combine the different layers. That said, probably the person asking has probably thought a little bit about the implications, because actually, for example, if you want to implement optimized rename, where you don't want to really copy the file, or if you have hard links, actually you have to store to be able to store the information that a certain name maps to a certain inodes. So while the basic workings of UnionFS are actually based on path names, there are cases where we want to introduce merging based on inode as well. So it really depends on the functionality we want to put in UnionFS and how much the user wants to use. I intend to support hard links and fast rename in UnionFS. I'm not sure if it will make it for 15, because in the first version, production grade version, but I intend to support that actually. So I would say, to answer your question, at first it will be based on paths, but there will be exceptions when necessary to support more efficient operations or specific metadata operations in UnionFS.
Thank you for that question and answer. Anything else, or shall we segue? Rob, I hope we've set the stage adequately. Welcome.
Hi. Well, thank you. So I've mostly been following along as we've chatted about this over the last few months, sort of from the sidelines. So just trying to think about a little bit of structure around this. I guess something like UnionFS is very cool. I come from sort of Linux originally, and I know OverlayFS pretty well there, and I use it, well enough when appropriate. I would like to bring a lot of my things to FreeBSD, so having a similar tool there will be nice, but that's sort of by the by. That's not ZFS related as such. So in the past, I know, Michael, you mentioned it earlier. Alan did started a bit of a prototype of like how we might do something like this, like within ZFS itself, because obviously it's a box containing multiple file systems. How would we make them talk to each other? How could we within ZFS itself create a data set that is like, this data set is composed of a bunch of other data sets in interesting ways. And like, as I recall, there's not a lot to show. It's a very early prototype. And one of the big challenges was when you read over read basically, when you try to take a list of all the files in a directory, you can do that in pieces. For first call, I get the first N, next call, I get the next N. And the challenge was how to actually maintain like a stable position across multiple directories that are being combined into a single sort of virtual directory. I don't think it's an insurmountable problem, but for a prototype, it wasn't entirely clear exactly the right way to track that. So that's fine. But I guess for me, the kind of questions are at this point, something like UnionFS or similarly OpenZFS or whatever, it sits atop it's kind of a VFS layer proxy, if you like. It's making different calls into different file systems and kind of taking the results and then presenting them as a new file system. But like I say, ZFS already knows some stuff about its different file systems and things like, it knows what a snapshot is. It knows, it might have some different conceptions of that. So I guess, and these aren't really specific questions, but these are like, what can ZFS do what facilities can it have to support something like a UnionFS? In the same way we have, like, say, copy offloading. You can copy a file yourself, or you can ask the thing that's smarter to do the copy. Is there something that a UnionFS could say, hey, you know about these two things, you own these two things, can you do some cleverer magic for me so I don't have to brute force it? So there's those shape of things. Maybe there is something where ZFS should have a limited UnionFS style thing internally like this, a data set made of other data sets that would be more portable, that would be like all inside the ZFS box. Maybe it shouldn't be. Maybe this is like, a facility like a UnionFS clearly belongs over next to the VFS, and file systems should stay out of the way. It's always going to integrate better with the platform if it knows those file systems, that system's kind of, idioms, like what does this look like on Windows? What does this look like on macOS? What does this look like? So those are my vague shape of questions as a ZFS developer, because I'm like, well, what do I have to build here? What would be the most useful tools to build? And they're kind of vague questions without answers, but they're kind of my particular interests. Sorry, Michael, I don't have a lot more specific than that.
Well, hopefully those questions are a perfect conversation starter for users in the room who have container workloads. Are there any of those?
So I guess I can expand a little bit on the prototype I started. My use case, again, was kind of jails and other related things where I wanted basically a data set mounted over top of another data set. So you'd have a read-only, very specifically read-only data set on the bottom. That would be like your base install of FreeBSD that we're going to reuse a whole bunch of times or something. And then maybe an empty data set on top of it that we can write into, and maybe there's some changes. And kind of using the paper I read and so on from Union Mount, which isn't the same as UnionFS, which allows you to basically mount two file systems to the same directory, and it can effectively do the simple thing of when we get enoent looking in the first directory, we look at the next file system and see if we can find the file you're looking for there. and that generally works. But the problem with readir is, because the user space program that's calling readir has a limited size buffer, so it reads the first n kilobytes or whatever of a directory. And as part of that, you get back a cookie, which in ZFS is the zap cursor pointer, which allows you to kind of, when you call readir again, pick up in the same place in that zap that you're iterating over and read the next chunk and the next chunk. And that works fine. But when you get to the end of the top file system zap and you want to transition to the next file system and start reading its zap, how do you pass when you're resuming and you're past the first level, the cookie is going to be for the second zap, but there's no way for it to tell you that you're in the second file system now. Right? We're using all 64 bits that we have for the cookie for the zap cursor already. Yeah. Basically a file system multiverse. So accessing an individual file was easy to prototype. Trying to list a directory that exists on both the top and bottom layers and kind of merge them together and display them is something I didn't get to work in the limited time I put into the prototype. And then you have the bigger problem of, if you have subdirectories, if you have one that exists in the top layer and then one that exists in the bottom layer and one that exists in both, how do you display them? Which date do you show for the directory for the last modified time and so on? And then once you go in the directory, how do we, get a lot further? And that I quickly discovered the reason why the initial paper on union mounts doesn't cover subdirectories is because it gets really complicated really fast.
So again, not being a person who really has these container workloads, but I'm wondering, is there anything in this application that either needs or at least would benefit from the transactional structure of ZFS, where you could actually, where either for reliability or for some other reason, you'd like to be able to do something atomically, in potentially across multiple layers, where you would actually benefit from implementing in ZFS directly.
In my use case, less so. It was more what I wanted was in the bottom layer is read-only, so I'm never going to change it, so that's okay. I did hope to eventually be able to swap it with a newer version, so I could switch the base of what the overlay was, what was under the overlay from 14.1 to 14.2. But the main thing was really that the top layer where I've made all the changes is ZFS, where I can snapshot it and replicate it. On an unrelated topic, I found somebody's GSOC project from 2020 to add auditing to NFSD. I'm trying to tell if it's in reasonable shape or not.
So, regarding all of that complexity, our FreeBSD readdir function, if I remember correctly, also has a stable sort inside of it to deduplicate the returned directory entries. Because if you have this kind of union mounting, it can happen that you have the same file in both layers with direct subdirectories and so on, and then you get two returns for the same path, basically, which breaks a bunch of user space code, which assumes that there can be only one. So that is a problem you also have to face, and that becomes hairy. What is strange about the hard linking from the overlay into the underlay is that now you have kind of a hard link to something which is not on the same file system, which is not what normal file system on this data structure support, which is if we think of the overlay as a patch, maybe what is missing is basically the merge conflict resolution, which should be its own thing as a little file you keep, which is then basically tracks both by inode and by name, as long as you use the same file system again and again. You can use the by inode for performance, and if you want to remove your patch and your resolution, you have to do a VLOOKUP and replace basically the name to inode mapping or inode to name mapping, so that the union overlay is not not fully featured on its own, but it needs this is the relation between the two. So that you only put the file content and the necessary directories to have the paths exist in there, but the metadata, which normally can't exist in a file system without relation between overlay and underlay, maybe that should exist as something which is not a file system, but more like a little database, which belongs to the UnionFS. It's just
this is exactly what I intend to do, for example, for hard link preservation in UnionFS. Basically, you have the two layers, and you have another piece of file system that should store this metadata that is not really modeled into the upper layer, but has to be persistent if you want it to be persistent. It's practically or even theoretically mandatory for hard links, for example. It is also if we want to keep more metadata on file that the actual file systems can store. I think the trick is that with UnionFS, you have at the basis, you have two independent file systems or two independent hierarchies of files. So that means that when you combine them, at the moment you create the union view, you combine them, but the trick is that you have no guarantee from the UnionFS driver that these two layers actually match or actually have been preserved correctly. For example, nothing prevents you from deleting some file from the lower layer and then recreating the union. In this case, that means that, for example, your inodes that you have stored in the upper layer or in the metadata part for the union will become stale in some cases. So it's not the trick. You can't really prevent that kind of independent modifications. So I think that the implementation in any case has to cope with that at runtime. So we'll try best depending on the options passed by administrator on a number of technical topics, but basically higher level. That would be rather would you like this union, for example, to be persistent or not? Because if you don't want it to be persistent, there are lots of things that we're not going to store or operations we're not going to do. But if you want it to be persistent, okay, we are guaranteeing some level of service. For example, we are preserving hard link, provided you are not going to mess up with the different layers offline, actually, out of the, I'm not sure it can really do something else.
There's nothing you can do about a malicious root user doing things offline and corrupting it, other than not panicking but catching the error and returning an IO error. But kind of what I was thinking when I looked at the problem is that you don't want to do it all ahead of time and walk both file system and pre-compute the merge, but you kind of have to do that lazily.
Yeah, absolutely. Because you don't.
But once you've done it, the problem now is that if you do it only in memory, you have to redo it every time. It has to be perfectly reproducible. But if you could just persist this per directory, so basically for each directory in the UnionFS database, which would almost look like a file system without files, would record the basically directory entries and whether the reference is to the over or underlay. So that you know now, okay, this is a directory and these are the entries in it, and they point to either the over or the underlay. And at some point you find a point, hopefully, where it exists only in one, and at that point you kind of hand it over and say, okay, this directory is unmodified, it's from the underlay, I don't have to look in the overlay because I know that. And if you directly bypass the UnionFS and modify the overlay, you get what you deserve, or there's a command to basically wipe that database down to the absolute minimum by name and re-index the rest as needed, so that you would basically only keep the by name thing. And what I was thinking is something like fh open, basically open by inode and generation on a classic UFS file system. Don't know how it maps to ZFS, but it is basically the same problem you have to give a file handle as an NFS server, where you have to have a stable reference to something which works across renames and yeah. So, and NFS user space daemons like the login daemon and start daemon used to just use fh open for this.
Yeah.
And this is kind of the reference you would have to store. And with some way to
but then
re-identify the file system as identical after a remount and especially a reboot. But that's a lot more than just the minimal UnionFS. That's okay, let's hope it comes in for 16 instead of 15.
But the trick is that I'm not completely. I clearly see what you mean. I had some reflections on that point, but I'm really wondering if it's. I mean, there are cases where you really want to store inode or inode numbers, but these are mostly corner cases, I would say. Yeah, and you say, okay, we want to, in some cases, we would like, for example, if we know that some directory has not been modified in the union. So basically, it's the same as, let's say, the pristine copy, which is in the underlay. But what do you gain by doing that? Actually, you can gain maybe some speed up, but the trick is that it's almost basically as if you were trying to second guess what the underlay is going to look like. And do we really need to do that? I mean, we have lots of caching for file systems. So it's true that when you first start up the system, you're going to have to figure out different things. That is to say, okay, I have this path. I'm going to access it through the union. So the system has to check whether this path exists in the overlay and then in the underlay. So it takes a little bit of time. But once you've done that, you can cache the results. And then, so does it really matter, from a performance point of view? In the long run, probably it doesn't really matter that much. Maybe in some scenarios where you have to be fast and recover fast, for example, maybe it has an influence, but I'm not completely sure it's worth it. And it has security implications. Doing some shortcuts usually has important security implications. For example, if we start storing inode numbers in the upper layer, and they are pointing directly to some files in the underlay, and actually these files have been deleted, and the inode number has been recycled. Maybe it's not frequent occurrence, for example, in ZFS, I don't know. But I know that for UFS, for example, it could happen. And then once you have the file handle, if you are able to access the file directly without any control, basically we have the same problem with that NFS has, which is possible security or permission bypass.
Sure, it would become a confused deputy by design if the caller is untrusted. But as long as you're inside the kernel, and I'm not saying that the hard link to the underlay should ever be written to the overlay as a normal as a special kind of hard link with a it's an UnionFS hard link flag, and it can reference any arbitrary thing, but that as long as the underlay is read-only, so it will not at runtime while the UnionFS is mounted change. And you're basically storing that not in the piece which I would consider the overlay, but in the union, it would be materialized as like the union should be its own thing, so that you have a underlay, an overlay, and then the union, which is stored probably not as a file system but as a database file somewhere, which is just understood by the UnionFS.
Yeah, I'm not completely sure if it's yeah.
And I'm not sure either. It's just where I ended up and gave up.
Olivia had a question in the chat of where is the best place to discuss these architectural issues. Any file systems mailing list in FreeBSD land or place of choice? Okay, so Olivia, Rod suggests the file systems mailing list.
I think we have we have a file system mailing list in FreeBSD. That would be a great place. If you don't really know where to send that, if it's specific to UnionFS, you could send it to me directly. Obviously, then I will try to repost it because it's best. I mean, this is the public information, and obviously we want to share it. So starting some threads on FS at freebsd.org would be nice.
Okay, so bringing it home to OpenZFS, are there any obvious opportunities that are relatively low-hanging fruit, or do we wait for your work to complete? Rob, is that project you saw out of Alan something to put some time into, or where are we at? Rob, I value your take on this.
From OpenZFS point of view, I see, as I say, the like UnionFS in FreeBSD or OpenZFS in Linux or other systems. I see that as somewhat related, but not the same thing, because, as I was saying before, if ZFS could do something unique or be made to work better with those kind of things, I would be wanting to look at how to support them all. Like, I'm definitely interested in following along with UnionFS development and that sort of thing, because I like FreeBSD and I'm interested in file systems, and Olivier's a nice guy. There's plenty of good reasons for me to do that, but yeah. So if you've got use cases that use specific ZFS concepts, I suppose, like how will this thing play with snapshots, or what are the additional overheads of having, multiple zaps doing things or whatever. I don't even know. Again, I don't have a particular thing. Those are the ones I want to hear about, because they may be like, cool, well, we can build that, but how do we make it work with UnionFS and OverlayFS and, I don't know, other things, other systems, union mounts on Windows or something like that, because all those, if ZFS is going to be available on all operating systems everywhere, as it is my 50-year plan, it helps to start thinking about those things right from the start for me. Don't worry, I'll ask better questions when I have more concrete things in front of me.
Okay, well, great. We have a large audience. Any questions from the audience? Yes, go ahead and let's wrap this up and start caffeinating for those of us who are dragging.
This may be a broader question than we want to get into, but there's an enormous amount of infrastructure that ZFS has particularly like sitting right underneath ZPL, that would potentially be useful to build something like this. So you don't have to go out and re-implement your own key value store because there's already one that's in the file system you're sitting on top of. And I know there have been attempts for previous sorts of things that aren't really related to this to actually expose some more of that functionality so that you can use it to implement, other kinds of file systems or what have you. And I'm wondering, how much, stomach is there for that sort of thing to actually make these be sort of more first-class interfaces.
That reminds me of the old discussion of the object or block level to ZFS, like how should you expose the DMUs to support cluster file systems like Lustre on ZFS directly.
I may have, maybe it's not completely related to what you said, but I have some food for thought maybe on what Rob said just before, so probably we'll talk about that as a follow-up, because I have some kind of ideas of how ZFS could help. I'm not completely sure if it can do something unique, but maybe we can probably talk about that. So one of the interesting things in ZFS is that it has a view of all the different layers. And for example, it has now block cloning. Typically in UnionFS systems, when you want, when you actually modify a file, you have to copy it up to the upper layer. And usually this copy is a full copy. So obviously, if you're modifying really big files, it can be a problem, which is, I would say, if I understand correctly, today mostly a problem solved already because we have this copy file range. So, and UnionFS will be changed to use copy file range, obviously. So that means that we could have very fast copy ups even for big files because we are not really copying it. There are other possibilities for to store UnionFS metadata efficiently. I have some experimental ideas also about storing new metadata that UnionFS usually don't store. For example, for whiteouts, I would like, if possible, to have whiteouts that are tied to direct. Normally, whiteouts are directory entries, at least conceptually. On Linux, for example, there are multiple block devices, if I remember well. That means that you have different files, but these are different files, but UnionFS doesn't really require that. It just requires that you have some mean to say, okay, this path, it's a whiteout, but it's just a path. It's not at the level of the file. And in some scenarios, I think it would be beneficial, for example, to store metadata on entries, which some file systems don't do. Actually, UFS doesn't do that. UFS for directory.
What about using extended attributes in the system namespace?
Yeah, the extended attributes have the same problem, is that they are tied to files, not entries.
Yeah, okay. With entries, you really meant directory entries. Okay.
Okay, we've set the stage. How about we keep track of our questions and take it to a combination of the production user calls and mailing lists. And if anyone has some final thoughts, perhaps we'll call it good and reconvene soon. Thank you so much, gentlemen. Did I see a finger? We're good? Okay. Thank you. Merci. Cheers. Danke. We'll clap.
Thanks.